Hi guys. Just remember when we were looking at those two disco lights, I mentioned that he actually brought me three, and I thought the third one was probably just not set right. I was a bit wrong. It's faulty. I'm pretty sure this is faulty. This is, I guess it's like a stage light, up light, so it's on like a kind of a stand, or it can be mounted like so. Problem with this one, if I just find a paraboloid, one moment. Should have prepared that earlier, shouldn't I? Okay, so the problem with this one is that only the red is working. It's reacting to sound, but no matter what I do with the controls on this, I took the manual into test mode, I can only get red. So I'm guessing that's what's wrong with it. Unfortunately, the customer says red is his least favourite colour, so we're going to have to get a few more like this. This one, he just wants me to have a look to see what the problem is and quote him a price for repair, because it actually belongs to the owner of one of the bars that he normally works in. So let's have a look. I'll just take the back bracket off it so we can get to the thing, and we can have a look and see what's inside this one, and hopefully figure out what's wrong with it. I'm guessing if it's not going to be oh, that's better. If it's not going to be too expensive to repair this, then the customer will be happy. That's a bit of a balance to this, you know. When somebody asks for a quotation, is you don't know if you're actually going to get the repair job or not. So, you know, it's maybe not spend too much time. The way I normally work, by the way, on paying repair jobs like these, is I sort of say, look, if I can fix it for about 40-45 euros or less, I'll just do it. I won't bother to let you know. I'll just get the job done, yeah? If it's going to be more than that, I'll give you a call and give you a price, and then you can let me know if you want it fixing or not. Mostly people say yeah. Occasionally they say no. When they say no, they quite often say, oh, keep it for spares. So, you know, it's not a total loss of time. You can, you know, in that case, you can either repair it yourself for the cost of parts and then sell it, so you get your time back, or you can just use it for bits. I mean, you know, you will not fix everything in this game, I'll tell you now. You know, no matter how much experience you have, you will not fix everything. And sometimes because you know what's wrong with it, but you can't get the parts. Sometimes because you know what's wrong with it, but you can't fix it. You know, damage to the circuit board. I mean, sometimes you can repair that, but sometimes, you know, if something's burnt up through or something, you know, you just can't fix it. And sometimes, I'll be honest with you, sometimes you just cannot figure out what is wrong with something. You can't analyse the fault. I'd probably suggest, you know, maybe 1 in 10 times I look at something, I just can't figure out what the fault is. Motherboard's a little bit worse for that. Motherboards can be quite tricky to repair, and I'd say that being able to determine what the problem is, maybe if you have, you know, quite a lot of experience, you might be able to find the fault 60%, 70% of the time, but probably still 30% of the time you can't, or you're not really sure. With those ones, I tend to put them on one side. If these things I've bought on the basis I'll fix it, I tend to stick them on one side and just wait. And then, you know, what sometimes happens is, this is proving difficult, what sometimes happens is, a couple of months later, you'll fix something else and you think, hang on a sec, I think that's probably helped me to fix the one I had before. Or you may, sometimes you might get another one of the same sort that's working, or that you've fixed and got it working, and then you can use that one to make a comparison to see what's wrong with the other one. So I'm making some strenuous noises. The last two screws in this are proving extremely difficult to remove. So yeah, as I was saying, don't think you're going to fix everything. Okay, we should be down to the last screw. I'm assuming this is how this comes apart. Just take the back panel off. I mean, I don't know, but it seems reasonable that it will come apart that way. So these screws, the head's a little bit corroded. I think I might have mentioned this before. We get this corrosion here mainly because we're surrounded by the ocean. You know, this island's 25 miles in diameter, so the furthest you can be from the ocean here is about 12 miles in any direction. And it's the salt in the air from the ocean. I think that's what causes this corrosion. It's not, as I say, it hardly ever rains. And when it does rain, it has the decency to do it at night for the main part. You know, I mean, what a bit of rain we see almost always comes in the night, leaving it sunny in the daytime. So that's quite decent of the weather to do that. There were some little screws. The back of this still won't come off. I'll take these four off. I'm assuming these four. I'm pretty much assuming are holding the circuit board on the back or something like that. I don't know exactly until I manage to get it open. Let me know, guys, if you know, in the comments. You know, do you prefer me to do this from scratch? So I pick something up, open it up, and repair it, or would you prefer me to just, you know, get the thing open first, and then, or you know, show you then get it open first, you know, off camera, because you could knock 5 minutes off these videos, you know. So let me know how you prefer. Do you prefer me to do the whole job? You know, I'm trying to do, you know, reality. This is reality. This is exactly as it happened. Or do you prefer me to, you know, make the videos a bit shorter by you're not having to watch this stuff? Okay. So it looks like it's coming apart. This is, I don't know if I mentioned, it's a Starville. Yeah, I think I did mention that. Okay, that's coming apart, but not easily. Looking inside, can you see inside that? I think this is going to be another one of those with the four individual power supplies, one for each colour. It's now kind of like held together by all the interconnecting cables, so I think we need to this slide out. Yeah, I suspect these corner pieces will come off, and I can lift that off, and then I can probably get into the thing. Into the thing and have a look to see what's in there. But just glancing inside, this looks to be like the number 2 one we fixed with 4 individual power supplies, one for each colour. I did notice actually on the label for this, it says it's a HL-X9 and this is RGBW. So no confusion with this one, it's red, green, blue, white. So at least we know what we're looking at this time. That screw just seems to hold on like some earthing leads. It doesn't seem to do anything particularly. I bet this one's getting back into this metal piece. I mean, sometimes, you know, you'll do all this to actually get something apart, then realise actually you didn't have to do all that. And if you just took the other panel off, you'd have been in there straight away. Too many screws. This is unplugged, by the way. if you notice. I know I have actually got it unplugged, sticking by my own rules I'm trying to teach people. Okay, these move now, and it looks like this is held on by one screw here. Try a different screwdriver, that one's not fitting very well in this one. That seems a bit better. There we are. So, can we get any further into this? Let's have a look. Yeah, now it turns out that I should have just taken the front off, I think. I'm looking down inside here, and it looks like these four pillars, these metal pillars, are held on by screws from the front. And if I take those out, it looks like the whole thing will come out backwards. So, as I said, sometimes you just, you get it wrong, and you're figuring out how to get these apart. Okay, these are coming out. It's like two more. You watch all these will fall out. You'll have the devil's own job to put it back together again. I'm sure that's what will happen. Let's see. But we need to get in there. We've got to get in and have a look to see what's wrong with this. I'm guessing we've got we've got 9. It says the 8 watt LEDs. I'm guessing it's 2 watts for each colour, red, green, blue, white. That's 2 plus 2 plus 2 plus 2 gives 8. So these LEDs are like quad colour LEDs. Okay. Does it now come apart? To some extent, yes. It's now all held together by all the earth tags. Oh, did they make this hard to get into it? Did they make this hard? Every little panel is, well, those two are free. Yeah, it's made very well. You've got these earth wires which are going everywhere, so they're effectively holding every single panel together. So we still can't get in it easily, but we can see what we've got now. Yeah, do you see that? Do you recognise that? 4 power supplies, 1 for each colour. So that's what we have. How are we going to get into this thing? I think the best thing is here. I'm going to take the circuit board off the back because I can test the LEDs individually. So yeah, let's not mess around with all these bolts. Let's just get the circuit board out. So find the flat blade. So this is your mains coming in. Yeah. And this one is your LEDs going out down here, the 4 colours. Let's just do the thing as we did before, so just grab a photo of that so we know which is which. Just got a photo there of the, if you can see it reflected on the phone. Let's have a photo of the wires. I know again from the other one you have a plus and minus on each of these. Yeah, the bottom one's the black stripe. If you get these the wrong way round, it won't do any harm. They just won't light up. But probably like the wires, like the way it's been, bent, formed when it's initially fitted, will pretty much hold the wires like in place, in the right order anyway. So you shouldn't have too much problem when you can put this back together. But again, the one with the black stripe is towards the bottom end. top end, whichever end you want to call it. White stripe at the top. If you remember white stripes, name of a band, then you're nearly all the right way around. Okay, let's get further in. Okay, we're in. This one's going to the cooling fan. It's held in by glue, as often you find the stage lights. There's glue on all the connectors, because obviously it's getting, it's out on the road, it's getting knocked about. So they do that to basically make sure the connectors all stay in place. Can we just free that one? Yeah, there we go. That's out. So there's just these two earthing pins, and there's a control cable coming in here from the controller. So we're getting there, guys. Doesn't fit very well. That one does, but the nut's just spinning. Yeah, they're nylon nuts again, obviously, so the earthing pins don't come loose. I should be able to get a pair of pliers on this one. If not, I have to get a little spanner set out. But let's see if we can just get a grip on that one. Yep. That's off. And this one's from the top. It's a little bit easier, I hope. That one's off. Just lost a little star washer. Got that. Okay, folks. 10 minutes are we in? 17 minutes into the video and I've actually managed to get to the part. Once again, this connector down here is held in with glue, so see if I can just, yep. You want to be careful with these when they're glued in. Sometimes you pull them off and the entire plastic, the base part, comes off as well. And then sometimes you end up with bent pins. Okay, that's a part. What do you see? First thing, it's filthy. It's filthy. This could be a candidate for going in the sink, but to be quite honest, I'm just trying to diagnose the fault first. I'm just going to get a paintbrush and hold this over the litter bin. You won't just see this under the desk. And just brush the worst of the dirt and dust and grime from this one. One moment. Yeah, sorry about it, just a phone call. Well, I can see what's wrong with this one. This is fell out. You can see that thing that's fell out of there. And you can see where it comes from. This one, blown its top, literally. So these four, 1, 2, 3, 4, including the burnt one, these are the controllers for each of these transformers, and we can quite clearly see that this one's, say, blown its top. That's gone. Then we'll have, this is much like the other ones, big input capacitor, bridge rectifier. So we power in, fuse, thermistor, 2 capacitors from live to neutral, 2 coils, so it comes through the coil. So basically live, if it is, obviously you get which way the plug's around, we'll call it live in through the coil to one AC input on here, neutral through the thermistor, through the coil to the other AC input. Plus and minus from here. This is the negative of the capacitor. This goes minus to minus, plus to plus. This has about 300 volts in. You've then got some little, possibly these little low value resistors. Could be high. You've got another capacitor for each of the power supplies. Yeah, these are rated at 400 volts. So these are high voltage capacitors. One for each of these power supply things. I wonder what this resistor is here. Just because you've got one of these. I wonder if that's like a current limiting or something like that. Just wondering why each one has a resistor there. And I think it's a low value one. Let's have a quick look on the meter. Yeah, like 1.7 ohms. That one's blown, I think. Oh, it's not a resistor, it's a coil. It says L4, L3. Yeah, it's a little inductor. Stop sparks getting back into the mains again. That one's good. This one I think looked like it was open circuit. No, it's good. This one on the blown channel, I think. That looks like that one's open circuit. I'm pretty sure. Let's have a look at the one at the end. Yeah, that one's. So this one here was open circuit. I'm sure it on the channel it's blown. No, it's swiney thing. It gets some. Unless I'm making a bad connection, that's open circuit because I saw a connection at one time. Yeah, I've got a connection, but it is a bit low. Maybe that inductor's damaged inside. You know, short circuit turns. It probably goes to this one. I know there's no power in this big capacitor because it was working with the red light lit, and when I switched it off, the red light faded out. So I know that the power's all drained out of it. That's why I'm not too worried about high voltage in here. If it had been completely dead, yeah, we'd have to be checking it was safe first before we start probing around it. So that's what's wrong with one channel. I suspect probably it's what's wrong with the other ones as well. I suspect 3 of these have blown. I suspect, you know, it's not proven yet, but I suspect that 3 of these have blown, and one's actually gone bang. Why did it go bang? First thing is, have we got any short circuits on the output? You know, just see if we can figure out why this actually went bang. Easiest place is just check across the LED connectors. That's high. That's high resistance. There's no shorts on those two, not on that one. Nothing obvious. No shorts there. If there was a short circuit diode, I'm pretty sure I'd see a short circuit here. But we can take the board off and have a quick look to see if we can see anything else underneath this. Okay. Nothing obviously burnt underneath. Bit dusty, but I don't see any like arcing or, you know, blackened areas where something's exploded basically. The diodes, which are down here, which are a double diode package, 3 legs, they come here. Oh yeah. Can you see? I'm sure, yeah, that focuses well enough. You've got like 3 pins, 1, 2, 3 here. Those the one, no, here, sorry. 3 in a row, that's 1. 3 in a row, that's 2. 3 in a row, that's 3, and then number 4, yeah. So those are the actual output diodes. So let's have a quick look, see if anything short here. In fact, I'll put it on the diode range, yeah, and you should see the forward voltage drop of the diode now. So let's go for the first one. Yeah, 611, 539. Do you remember the last one we were reading? We're getting basically the same. 539, 611. I think we can say this is basically the same, maybe even the same manufacturer. Pretty much it's the same diode. So these are all okay. Yeah, no shorts. I think this has just gone bang for no particular reason. Maybe, you know, they run a very close tolerance. So yeah, let's see what these devices are. Let's see what they actually are. Let's get the microscope. Let's have a quick look, see what these things actually are. Yeah. So that's a good one. TNY. Yeah, these are power supplies. Tiny Electronics or something like that. Tiny. And the manufacturer, I think, TNY 280PN. Oh dear. TNY 280PN, TNY 280PM. Let's have a quick look as well. I'm just trying to determine, I mean obviously I'll probably have to power this thing back up again and have a look to see what's wrong. We know what's wrong with this channel for sure. And that maybe if I compare the working channel with the others I can get some idea if you know what the fault is on the other ones. But anyway, let's there's 2 diodes just down the side of each of these. Be interested to see if any shorts there, because I suspect these feed the power back from the secondary of this. One might be on the primary. What I don't see on this one, well, let's get the camera so you can see it. How did we do it last time? We put the desk cam on top, and now we made it smaller. There we go. Okay. So we're still on diode range. That's a good diode, 478. The other way you'd read nothing. See it? Yeah, nothing. This is the other way around, so this should. Sorry, this is the other way around, so they should read nothing. Oh, I'm in the wrong place, aren't I? I'm in the wrong place. That's a good one. That's the other way around, so this way around. That's a good one, yeah. And they should read nothing. Same with the next channel, which is the one that's gone bang. Nothing. That's a good one. So the other one will read the other way. It's a good one. Nothing. Okay, that's a bad one, boy. Where's the next one? There's it. Oh, cross a bit there. This one. It's a good one. So all the way around on the other one should be good. Bring that onto the end. Yeah, that's good. And then the other way around, they'll both read open. Open, and then with the last channel. Obviously, we don't know which of the 3 that haven't blown up is one that's working. It's a good one. All the way on the other one. It's a good one. And then this way around, they should both read nothing. 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 Right, so that reads okay. We know there's no short on the input because one channel's working. One of these inductors looks a little bit suspect. Okay, let's have a look at this chip TNY280 because we need at least one of them. Let's have a look to see how much those things are. I hope this is going to work. I'm not sure if I've made this too small. Yeah, you perhaps can't see what I'm doing on screen, but it didn't quite look right. Hope this is going to capture the screen properly. I'm just going to pause the recording here and see if I've actually got the screen capture working properly, because it looks a bit strange on my screen. One moment. Okay, so yeah, screen capture is good. So let's have a look at this this part and see what it is. So, well, in fact, we know what it is. TNY 280 PN 280 PN. Yeah, that's a company. That'll be a company selling them. I can probably get the data sheet from here, but I usually go to this one, all data sheet. It's usually the quickest, shortest way to get to the PDF. Okay. Yep. This is similar to the other one. The rabbit notice only has 4 pins, and it doesn't have, you know, like another secondary from here feeding this capacitor, which will be the startup. This will internally have like a diode resistor startup, I would think. Let's have a look. It'll probably give us some information. Yeah, drain and source. Effectively is a FET, and then enable, and what's BPM? It'll tell us somewhere what these things are. Just a typical application here. Oh, funny, I thought it would actually tell you what those pins are. All the ratings. This is just ratings. A test circuit. No doubt it does tell you what all the pins do. You just have to, in this one, just read through. Oh, it tells you here. Like, bypass multifunction has multiple functions. Yes, that's why it's called multifunction. Mode selective current limit, current limit. Blah 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 blah. Blah 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 blah. Shutdown function. Okay, but basically we know what it is. It's basically a it's a FET with a controller built in for power supplies. Let's have a look, see if we can actually get these things quite easily. So AliExpress is where I find it easier based here in the Canaries to get stuff from AliExpress than from anywhere else. So that's my normal first port of call. Disadvantage, you have to wait a while, but to be quite honest, you have to wait a while for anything to arrive here. TMY 28TPN. Let's have a look. Yeah, here we go. 10 for €1.71. Well, that's cheap enough, isn't it? Have I even got any of these in my little stash of bits? I mean, I've got TMY. No, I don't think I have. But we can know for like €1.70 we can get 10 of them, yeah? As long as none of these transformers have blown, so they've open circuit, then there's nothing else on here that would be expensive to replace. We can have a quick look at the. Sorry, I've left you on the screen. My fault. Let's go back to the library. Okay. Desk. Okay. And microscope. No, we'll stay on the desk. Don't need the microscope right now. Okay. So basically, looking at this board, as I was saying, there's nothing on here really. We know these we can get 10 of these for next to nothing. There's nothing else on here that is likely to be expensive or difficult to replace, unless some of these transformers have blown, in which case you probably won't get a replacement. But we can just have a quick look at that actually. We can just, I can't tell for 100% doing this, but I can see if any of them are open circuit. I can't tell if there's any shorted turns in here, but that's one of them. 1.2, 1.2, 1.2, 1.2. That's all the primary side. I doubt they will have burnt out on the secondary side. I mean, if these controller chips have failed, it's possible you might have got an open circuit on the primary. I don't think this is going to tell us anything on the secondary, but let's have a look. 0.7, 0.7, 0.7. They basically look okay. So I think certainly that one and probably the other ones, if we replace these faulty chips, and remember that this is for quotations, so I don't want to spend a lot of time to prove that. If it isn't that, anything else it isn't going to be expensive. So that's that. The last thing we need to do before we can give a quote on this one is just have a look to see if the LEDs are actually working. It's a bit odd to get into that, but I can get to the wires here. And from here I can probably test the LEDs. So what voltage do they run on? Well, it's not so much a matter of what voltage they run on, it's more like what current do they draw, because these will be constant currents. These will be effectively be constant current supplies. So I think a 2 watt LED, and bear in mind these will be 4 2 watts, so for the 4 colours 2 watts each. I think the 2 watt LED probably draws, well, let's have a look. I bet it's like 20-30 milliamps. It might be a bit more. I haven't really worked that out, but let's see, we just find out in general what a 2 watt LED requires. Yeah, so let's go back over here again. Let's go and Google and see what it says. So 2 watt LED current. Yeah. See what a typical current is. How many amps does a 1 watt draw? 0.3. 300 milliamps. Yeah, okay. That's for 1 watt. So I think if we stick that, that sort of current into these, that'll probably be fine. How much current does an LED use? That gives like a set. So it tells you for the small ones. It's not specifically to tell us. Okay, look, it doesn't matter. We know like about 300 milliamps is enough to light up a 1 watt. So what I can do is here now. Can I show you this? I need another camera, guys, to really show you this. So you kind of have to like I explain to you what I'm doing here. Let's go back into the which one do we want? Don't want screen capture desk. Okay. So each of these colours, the 4 colours, wants like a few hundred milliamps or a couple hundred milliamps. So what I'm going to do is I'm going to take my bench power supply, which unfortunately you can't see, and I'm going to set it to constant current mode. And the way I do that basically is I'll set it. I don't know how many of these are in series. I don't know how many volts this actually needs, but we can find out. I'll set it resupply down to like about 5, 6, 7 volts. Let's say something like that. And I'm going to set the current so that it will not ever supply more than a certain current. So current supply on, and I'm going to set this down to about something safe. 500 milliamps, that's too much. Let's go down. 300 milliamps. I've set it down to about 200 milliamps, yeah? And now if I connect this to these, if I don't have enough voltage, they won't light up. If I've got enough voltage, then the power supply will automatically go to the correct voltage for the LEDs, and the current will go to what I've set it to, yeah? When I've got another camera I can show you this much clearer, but anyway, let's just try the whites. So there's no power flows, I haven't got enough voltage on there, so if I turn the voltage up and I should be able to get them to light up if they're good. 112. But I'll tell you what, let's try the red ones first, because we know the red ones work, yeah? We know the red ones work. I'm guessing, but I'm not sure, I'm guessing the black is the negative end, and that the other ones are positive end. I'll just turn the voltage down a bit. Okay, it's drawing no power, and now we just take the voltage up until it starts to draw some power. I bet it's about, yeah, there, you see? So we know the red are good, yeah? I've got 16 volts and it's drawing 0.02 amps, about 20 milliamps. I've set the current to 20 milliamps. So we know around that 16 volts or so the red light up. The other colours will be a little bit higher, the voltage. So let's try the white ones now. Nothing, it's not drawing any power, just turn the voltage up a bit. Uh, 22. Yeah, there we got them, yeah? We lit up now, so about 24 volts. If I put this back onto the red at 24 volts, it'll still draw the same current. That's how this power supply works. So if I just go back to the red, we'll just draw the same. I can tell you what it says on the meter. Yeah, 20 milliamps. About 200 milliamps. So we know the white's working, we know the red's working. We can now quickly determine if the blue and the green are any good. Is this a negative one? No, it's a positive. One must have a black, yeah. Can't easily tell on the blue if it's got a black stripe. No, I'm guessing all the ones with the black stripes are coming down the same thing, yeah? It's hard to see the black against the blue. So let's go on to the blue one. Yeah, blue's good. And then what was it, green, yeah? Use the same principle, that all the negatives are all on the same bit of wire. Green, yeah? So okay, what do we know? We've got good LEDs. We've got one burnt out controller, and that we can buy 10 of these for like €2. I think that might even be free postage, you know. So the parts are cheap. There's nothing else that's going to cost any great amount of money to replace. We're pretty sure the transformers are good, as sure as we can be. So because the parts are so cheap, it's worth the risk here, you know. Even if we still can't fix it, we'll end up with some useful parts in our spare bits, and it didn't cost us very much, so we didn't really lose anything. So I'm going to go back to the guy on this one. It needs obviously some more work doing. I'm going to quote him and I say, look, it's going to be about 50, maybe up to €60, something like that, to repair this one. And if he's happy with that, I'll order the parts, and then when they turn up, we can get it repaired. Hope you enjoyed that video. That's not a repair, but hopefully give you some idea how to make a quotation. I'm not sure, maybe that was about 30 minutes or so, 30 or 40 minutes. I think that's a reasonable time to spend on a quotation job. If it's taking you longer than that, you really need to consider, is it worth my time to do this? Okay guys, see you on the next one.